chapter 11, page 399 is where it starts. Okay, these first three subsections within this chapter are all like special types of calculations. So you work them out just like you would work out anything else we've already done, milligrams or whatever. They just have different units. Okay, so for example, this first one is in units, different types of units, like penicillin units is one example. Heparin is another one that comes in units. So we're just going to work out some practice problems because they work out just like we worked out our other stuff. Okay, let's look at number 1 on 400. So the physician orders penicillin G potassium 750,000 units to be added to IV fluids for a post-op patient. The following label gives you what's available. So what's the order for?
7,500.
750,000?
Yes.
Units. Okay. Now, what else do we want to write up here? Okay. What other info do we need? How is the medicine available?
1 million units.
In what?
In units. Yes.
What does it say? 1 million units. Okay, and it says, here, see where it says the usual dosage. How hard to see.
Okay.
It's going to tell you how many units. It's going to tell you different strengths. So look, so now let's go ahead and read a question because we don't know what strength we need yet. It says, what volume of diluent should be added to the medication for the strength to be 500,000 units per milliliter? So how much are we adding there?
1.8.
Yeah, 1.8 milliliters. You'll see that's at the very bottom. It's so hard to see.
Yeah.
Magnifying glass.
Couldn't tell it was 1.8, 1.6.
Okay, now it says what volume of medication should be added to the IV fluid. So if that's one we're using, let's see. And the order is for 750 units. So let's put what's available. That's not really quite right. So what's available, we just said, in every
500,000, there's 1.8.
So what's our strength here? How many units per milliliter?
1.8.
That's how much diluent we added to make it the strength that it is. So what strength? The first question said. The strength that we're going to use is what?
500.
500 units per milliliter.
Okay.
You see one? Yeah. Okay. So that's what's available for us right now. That's how we mix it. Okay, so now we need to know what volume do we add. So using this, this is our order. So we want to know the volume. So what do we want to know? Milliliters. And then just do your dimensional analysis like we have been. Every milliliter we have 500,000 units. And our order is for 750,000 units. Okay? So what are you going to get? Yeah. Okay. That makes sense? Just like what we've been doing, except instead of like milligrams per milliliter, you're just doing units per milliliter. The exact same way you're working out. It's just a lot bigger numbers. Does that make sense? You want to work out one more?
Yes.
Let's work out that one.
Another big one. Number 2.
Oh, well, let's finish the questions on here anyway. So, should the residual medication be diluted to another dosage strength? I mean, I don't think so. I think that's pretty easy. So 150 milliliters. And there's really no reason for that to happen. So, okay, which syringe for injection should be used to prepare it? Which syringe would you use?
First.
Yeah, use the first one. It's going to be the most accurate. Good. Okay, let's look at number 2. Physician orders Pfizer pen. I guess it's that. 800,000 units to be added to the IV fluid. So our order is for what?
800,000.
Okay. Use the label on problem number 1, which we cannot really read for the calculation. Okay, so what amount of diluent is added to get the medication strength 250,000 units per milliliter?
4 milliliters.
Yeah, 4 milliliters. Okay, good. So now we know what's available. What is our dosage strength available?
250.
250,000 per milliliter. Okay, now what volume?
But it says 250 for every 4.
No. That's how much, there's a million units in the whole vial. Okay, so if I've got a vial, that's my hand. If I've got a vial of medicine, okay, and let's say it has powder in it. Make this make sense. Okay, provide tissue here. Okay, so if I've got this and it's got, let's say it has powder in it.
Okay.
Okay, if I put a whole lot of saline in here all the way up to the top, is the medicine going to be stronger or weaker? Well, weaker, right? If I put a little bit of fluid, is it going to be stronger or weaker?
Stronger.
Going to be stronger. Okay, that's the idea here with what you're adding in. So all these numbers are telling you on that label is how much to add in for a certain,
To make it that
to make it a specific strength.
Gotcha.
Okay? But there's a million units in the whole vial. So that's why if you add 4 milliliters, it's 250 because.
But if you just left it powder, then it'd be a million units.
Right.
Gotcha.
Okay, so the more like saline or whatever you're using, the more diluent you add, the weaker the medicine.
Gotcha.
Okay.
Okay.
So there's differing strengths depending on what you need the medicine for.
Okay.
Does that make sense?
Yes.
So right here, we've added 4 milliliters, and each milliliter has 250,000 units because there's a million in there total.
Good.
Good with that?
Good.
Okay. So that's that's it. So what volume would we prepare for their dose? So how am I going to set this up? We want the volume, so what do we want this to be over here?
Milliliters.
Milliliters.
We got 250 over 1.
Yeah, well, I do the milliliters on top. Remember, you always want to do this on top over here, otherwise you're going to get like it's going to be, and your answer is going to be inverted,
Okay.
and it's going to mess you up. So that's why I always start by putting that one on there, because I want to make sure that whatever my units are, I want to end up with, they're on top of it.
Okay.
And then our order is for 800,000.
And you divide the two, wouldn't you?
And you, yeah. 85 by 25, which is
3.2.
3.2 milliliters, okay?
Okay.
So it's just the same. If this was 250,000 milligrams, that's questions we've already been working out.
Okay.
All you're doing is changing it to units, and you're just doing bigger numbers because units count. That's how units are.
So to get 800 units, you would take 3.2 milliliters of the 250,000 a milliliter. You know what I'm saying?
Yes.
Okay. Okay.
Yes. Yeah. If you were to multiply this by this, you're going to get 800,000.
Okay. I got you.
Got it now? Okay, now it says, what volume of medication would remain in the vial following preparation of the ordered medicine?
0.8 milliliters.
Yes. Even though that technically doesn't really give us a powder volume, but that's just what it says. So. Show the documentation that we needed in the vial on the vial using today's date and time as. Because this can be kept solution for 1 week. So you want to put I guess you just want to put the date. That's what it's asking for. Put your name and the date. Okay. Okay, now it says, how long would the medication be stable following reconstitution? I just read that. Or good for a week. I just said that on the label. And then what syringe would you use to add this in?
The second one.
The second one. Yeah. Okay, good. All right, any more questions on those?
So would you put like 3.2, like when you pulled it back, would you put like 3.2 of air in there to repressurize your vial?
Yes. Yeah. Yeah, if you don't, it will squirt out of your vial at you. Whenever you pull whenever you take your needle back out. Well, one, it's hard to draw up medicine whenever you don't pressurize it because it's going to all want to go back in the vial. And then whenever you take that out, it's going to like shoot medicine out because the pressure changes. So yes, you want to always replace, the same amount of air in your vial as medicine that you're taking out. Okay, let's go on to 409. Let's look at insulin units. Same idea here. Okay, it's just like this. We're just going to change out our units now for insulin units. Now on 410, it gives you all different pictures of different types of units, and what they're wanting you to do is just practice looking for the right kind of insulin because there's so many different types of insulin that you always want to read it and reread it and make sure you get the right one. Okay? They're all different. It has all of the insulin syringes over here. That U100 that's on all of these, that just means there's 100 units per milliliter. Okay, that's kind of standard. So again, always make sure that you look at them and check them. Not all insulins can be mixed. You can't, like maybe they're supposed to get 2 different types of insulin, and that happens a lot because maybe they need one that acts now and one that acts later. You can't always mix them, so that's always something to check. What can you mix and what can't you mix? On 412, there's a whole little chart with different insulins. That's a really good chart that you'll not want to copy anyway. You can just keep to have. All right, let's do these practice problems. Let's just do number 1 on here. 414, it says physician orders Humulin N insulin 45 units subcutaneously to be given every morning. Okay. Humulin N insulin 45 units to be given. Which vial would you use for this?
Probably B, where it says Humulin N.
D, yes.
D.
Right. Humulin N.
Sorry.
D.
Just kidding. D.
That's why you got to check on it. Because you have R, so you have Humulin R, you have Humulin N, and then you have Humulin 70-30. 70-30 gives you a percentage of or medium acting to short acting.
Well, I was looking on page 410 instead of the page up for it.
Oh, sorry. It's 413. Okay, so we know that we're going to use D. Which syringe would you give this?
45. I'd probably just give A.
Yes.
B
Because
just
it's
read
going to be the most accurate again. You could give B if you had to, but it would be a lot harder to measure the exact amount of units on that syringe. Okay, number 2, physician orders Humulin R 30 units subcutaneously 30 minutes before meals for a person with poor eyesight.
A.
Which is always something to consider because a lot of people who have diabetes do have poor eyesight because it's damaged their eyesight. Okay, so which vial would you use?
A.
A. Okay, which syringe would you use here?
Probably just B.
30 minutes, yeah. All right, let's see if we can find something we actually have to work out. You may not need.
B, why would you, B, is B just like blown up because B looks bigger than A? Like, you know what I'm saying?
Maybe.
mean, I can understand like if it was narrower, but it's like longer, wider.
It is narrower. It's a little narrower. Okay, look at number 11.
Okay.
Actually, let's look at 10.
Okay.
I want you to look at the NPH. Position orders Humulin 70, 30 units, and Humulin R 22 units every morning. Okay, so go back to your vials. Let's do this again.
You use A and E.
Yes. Okay. So good. Which syringe? Let me look. Says if you go back to 412, it says only regular insulin may be given IV. And that's one thing to know. Different types of insulin need to be administered at the same time. The same source of the insulin, such as DNA or recombinant sources, must be used together. Different sources of insulin cannot be mixed in the same syringe. If patients are changed from one source of insulin to another, from one manufacturer to another, they have to kind of recheck them. So regular is the only thing that you can mix with something else. Like you can't mix NPH and Lantus or something like that. You can usually mix regular, but then there's some that can't be mixed with anything. Like the really long-acting ones, they're not supposed to be mixed at all. Lantus is one, maybe not Lantus, but I know like 11 years is a really long-acting one, and it can't be mixed with anything. So if you mixed these two, which syringe would you want to use?
Probably A.
Yeah. Okay. And whenever, and it's kind of a whole big process. If you mix them, I shouldn't say that. It's been a long time since I've actually had to mix my own insulin. But okay, so let's say I've got two, and you're drawing these out. You actually would draw air up, like you draw 30 units of air, put it into this one, 22 units of air, put it into this one, draw up your 22 units here, then go back and draw up your 30 units out of there. Takes a little thought process when you're doing it that way. But it's not very often that you would actually do that. Oh, Lantus is the one that cannot be mixed. It says on number 11, Lantus insulin cannot be mixed with anything else. So you have to, so those two, for example, you have to get separately. On number 11 on 418.
So, like, would they just use like the needles and stuff one day?
You only use a needle per dose. If you get a new needle every dose.
Okay.
Yeah, that's always the case for anything. You always get a new
Right.
syringe for everything.
I don't know if you did it for.
Yeah, it's the same for insulin.
You're just using it on yourself. You just.
No, because I mean, you still need to grow bacteria and stuff. It needs to be sterile every time you use it. All right, good deal. Let's keep on going. Let's look at anticoagulant units on page 423. So heparin is something else that's used in your units. So this is going to work just like we did with the penicillin units. Let's go ahead and do the practice problem on 424. Number one, it says the physician orders heparin sodium 5,000 units subcutaneously. So what volume would we give? Okay, so what's the order for? 5,000 units. And what do we have available?
10,000 units per milliliter,
Okay.
1 milliliter.
10,000 units per milliliter. And the 1 milliliter is how much is in the vial. So how much medicine are we actually going to give them?
Just a half a milliliter.
Half a milliliter. Okay, let's do number two. Physician orders heparin 1,000 units sub-Q. Everybody remember what sub-Q means, right?
That's under polishment, isn't it?
It's a shorter needle that goes into like the fatty part of your skin, like adipose tissue. Like usually about half an inch needle, usually about half an inch. What did I say? 1,000 units.
Yes.
Okay. And how is it available?
10,000. And there's 1 milliliter, so you just use 0.10.
Point. Yeah, 0.1. Good.
It'll be alright. So what's the difference between international units and units?
International units are, I believe that's like your insulin ones that are 100 units per milliliter.
But is it the same?
No, like penicillin has different units. Well, you saw you can mix it however you want to. And you could make it as strong or as not strong as you wanted to. But insulin comes prepared already.
Right, but I'm saying is international units and units the same thing?
No.
As like in measurement?
No.
Okay.
Units are specific to a medication. So there is no it's not like a unit is not the same in insulin as it is for heparin, as it is for penicillin. They're different depending on the medication. Versus like a milligram is always the same. It's always weighs the same.
But a unit is not.
Right.
Gotcha. Good. So a unit is just a.
It depends on the medicine. It's like a unit of, I can't remember how it described it.
So you wouldn't say like a milligram of penicillin, you'd say a unit of penicillin.
Well, it depends
or
on.
1,000 units or whatever.
It depends on the type of penicillin and stuff too, how it's measured. But yeah. Okay, let's look at number 5 on here real quick. Physician orders heparin sodium 17,500 units. What is heparin?
That is a normal.
Heparin is an anticoagulant, kind of like Coumadin, but heparin is given IV, and this is what's given in the hospital. I have like maybe some trouble with blood clot or something like that. You might be on a heparin drip. Okay.
Wow.
So number 5, 17,500 units, subcutaneously stat. What volume should be administered to the patient? So what's available?
20,000 per milliliter, 1 milliliter. I'm gonna say 0.75 milliliter.
No.
Oh yeah, because 15 would be 0.75.
But anyway, let's work it out. So we don't want to guess. That's why we have the math, okay? Otherwise, you're going to get it wrong. Always check it. Okay? It's worth the 20 seconds it takes to do the math and check it than it is for that person to not make it through the day.
So you have milliliters over 20,000 and it's 17,500. So.
Is that what it is?
Okay, yeah, 0.75. I thought he was guessing the second whatever. No.
Okay. I'll tell you, the math here is easy. Here's why. Because you think 0.75 would be 15,000.
Yeah.
And then you've got half of that. So half of 0.25 is 0.125. So it's 0.75 plus 0.125. 0.875.
Yeah, sure, okay. You lost me like halfway through what you were saying. I mean, I kind of got what you were saying.
That's
But
you can do in your head. You just got to figure out where to add. Okay, so that's, any more questions about that? It's pretty straightforward. The units to me, that's all that. Milliequivalents is next, and it's the same way. So we're going to do, it's the milliequivalents works the same. 434. So that's physician orders potassium chloride, 16 milliequivalents to be added to their IV fluid. So what's the order for?
16.
16 milliequivalents. And milliequivalents are the same like we just said. They're not always the same for all types of medicine.
So it's just like another unit.
Just like a unit.
Gotcha.
Okay, so what's available? What's our strength available?
8 milliequivalents per
8 milliequivalents per milliliter?
Yeah, per 5 milliliters. Hey, are we on 1 or 2?
1.
We're on 1, homeboy. 40 milliequivalents, 2 milliequivalents per milliliter.
2 milliequivalents per milliliter. Sorry, I didn't say that. 2 milliequivalents per milliliter. Okay, so what volume are we going to add to
Get 16
set it
milliequivalents?
up? milliliter, you have 2 milliequivalents,
Yeah, 8 milliliters.
and you have 6 milliequivalents for your order. Yes, so 8 milliliters is what you're going to have. Okay, so this works exactly the same way. You're just doing milliequivalents, milligrams, or units.
Yeah, we do the same thing.
That's why I like dimensional analysis. That's why I like to work about this, because it works for so many different problems.
But when you started to add like 4 of those, it like threw me off, and I just started kept doing my proportions.
Yeah.
Then
You can keep doing
know
your
how to do it?
proportions. That's fine. You do whatever you want to do. I just like dimensional analysis because it's one step and I'm done.
Yeah.
I can put it all into the calculator at the same time. That's why I do that. If you want to do ratio proportions, that's how you make sure you get all of your steps. Okay. I don't have a problem with that at all.
Good deal.
Let's see.
Let's do 17.
Let's do number 8.
Good deal.
What do you want to do?
I don't know, because I was flipping through and I stopped. And
Oh yeah, we do. Okay, let's do 8. Physician orders sodium bicarb 3 milliequivalents per kilogram every 8 hours. What am I saying? 3 milliequivalents. And these will always be ordered in milliequivalents. You're not going to have to change milliequivalents. It's the same way with IV for a patient weighing 156 pounds. Medication available is 1 milliequivalent per milliliter.
70, you have
Now, what
70.9
volume should be
kilograms.
administered every 8 hours? So, what else do we need to know for this?
Well, your kilograms are going to be 70.9.
Okay,
82 milligrams.
70.9.
3 milligrams for every kilogram.
Okay. So,
212 milligrams.
so we want to know milliliters, right?
Sure.
So, in here, milliliters and milliequivalent, and then our order is for, oh, I'm sorry.
212. 47.
Yeah, I'm sorry, we should figure out how much they need. And you can, again, you can do that in one big step. So let's do this again. So milliliters, in every milliliter, we have 1 milliequivalent. And we know that we have, the order is for 3 milliequivalents for every kilogram.
Gotcha.
And then how much do they weigh?
70.9
kilograms. This is how you can add it all.
Okay.
And honestly, you could have even that. And you just multiply straight across, and then you just divide by whatever's on the bottom. So it's the same as well. What was it?
212.
Okay.
Very good.
All right. Let's look at number 17. See this label again. Physician orders magnesium sulfate, 150 milliequivalents to be added to IV fluids. What volume should be added to the fluids? Okay, so our order is for
150. You get 4 milliequivalents per milliliter.
150 milliequivalents.
4 milliliters.
Look at, oh, 4 milliequivalents per milliliter.
Yes.
Okay, so what volume they need 150 milliequivalents? How much do they need?
250.
You have trouble?
150 divided by 4, I think.
Yes.
3.4 milliliters.
Okay.
No. That's if you divide by 44, Bill, or Jake. Oh, I thought myself, Bill. 37.5. There we go.
37.5.
Better.
Milliliters. Okay. All right, let's get to this last one so that we get through with this. Okay, this one is a little bit, just a little bit trickier. Not hard. It's just a matter of setting it up. And let's read this on 441. The medications are also expressed in percentage and in ratio strength. Percentages and ratios are usually used for liquid and semi-solid medications to show the different strengths, such as 1% lidocaine, the percentage of medication strength in a solvent for injection used for local anesthesia, or like 1 to 10 sodium hypochlorite solution used for cleansing body fluid spills. So sometimes you get, like, for example, hydrocortisone. If you've ever used hydrocortisone, it usually says like 1%, or maybe it says 2% hydrocortisone. That's what we're talking about. As with all medications, the label found in a percentage or ratio requires reading the total volume amount of medication in the container, as well as the weight strength of the active ingredient or the drug's concentration and the total amount found in the container for correct interpretation. When interpreting the labels for percentage medications, the amount of medication is either in weight per weight. So like if you have a cream, you know, you might have 2 grams per 100 grams. Okay, so weight per weight. That makes sense? Depending on what type, if you have a solid medication, that's what it's going to be in. Or it could be in a solid in the liquid. So for example, like it said, 0.9% normal saline. The saline is technically a solid, and the solution you put it in is a liquid. So that gives you that 0.9%, tells you that there's 0.9 grams of sodium chloride in every 100 milliliters of the fluid. Makes sense? Give me a percentage. Remember percents. This is one thing you got to remember. Percents are always out of 100. Okay, that's one thing that can kind of mess your brain up when you're working on these. Or it could be a liquid in liquid. So look, in medications that are labeled as weight per weight, the number of grams is found in 100 grams of solvent. So we're looking at grams is going to be our unit of measurement for the most part here. So for example, 1% hydrocortisone cream would be there's 1 gram of the active ingredient for every 100 grams of the cream. Make sense? That's 1%. Okay, so look, so it has, I'm going to write this up here, percent weight over the weight is equal to number of grams in 100. It could be grams, it could be milliliters, whatever it is. Okay. So this could be grams or it could be milliliters, and this the same at the bottom down here. It could be grams or milliliters. So there's a formula on here you can use. It's just all they did to make this formula is if we're looking for the percentage here, they just did this like a normal ratio, multiplied this by the weight, multiplied this by the weight over here. That's how they got the formula on here. So let's just work this out so you can see it kind of practically. I know that sounds kind of crazy. Okay. Okay. I'm going to skip number 1 and we'll come back to the ratios in a minute. Let me get my brain going first. Look at number 2, 7.5% magnesium sulfate solution. Okay, so it's a solution. That means we know it's going to be a liquid, but it's 7.5% tells you that there's 7.5 grams in every 100 milliliters. It's a percent. Okay, so that's how you're going to set this up. So we know what this is wanting us to know. Look, it says using the following examples, interpret the meaning of the medication shown, and on the second line, indicate the weight of active ingredient. So what we're doing is we're just going to plug this in. We know we've got 7.5% is the weight over, we know it's 100 because it's a percent. So we know that's over 100 milliliters of the medication. Okay, and then we already know this is going to be 100 on this side, so X is what we're wanting to know. See, it said on the second line, indicate the weight of the active ingredient. That's up here. So X over 100 over here. So what is our active ingredient? What is this going to be? 7.5. Right? 7.5 over 100 is the same thing as 7.5 over 100. So 7.5 is our active ingredient index. Now that one obviously was pretty simple because we already had a percent going on. Let's look at number 3. It's gonna get this hanging here. 5%. going to be, your active ingredient is going to be 5 grams, okay, because it's a percentage. Let's look at, let's do number 9. I've got that answer in the back in case I get a little, my brain gets a little squirrely sometimes doing these.
I will answer that other one was in the back. That one that we had trouble with earlier.
No, only every third one is in here.
Oh.
Okay, so this one is giving us a ratio, so it's not necessarily 100, but it's still in grams. So that so number 9 on there, that 1 to 1,000, that gives us a ratio. That means that that means that there's 1 gram of the active ingredient, because remember these are always in grams unless it says otherwise, in every 1,000 milliliters. Okay, we're still wanting to know, active, the question says to indicate the weight of active ingredient in 100 milliliters. So we're wanting to know the active ingredient over here. Okay, so I'm just going to multiply this side times 100, multiply this side times 100 to get rid of that. And we've got 1/10, so it'd be what? 10.1.
Yeah.
0.1 grams is the amount of active ingredient.
Okay.
Look, 1/10.
Okay.
Okay. So let's go back and do number 1. Now that I worked that one out and saw it from the ending here. So number 1, we've got 1 gram. Okay, in every 10,000 milliliters. And we're wanting to know the active ingredient. So X up here over 100, right? So same idea.
You just have 0.01 there.
0.01.
Gotcha.
Okay. So let's look at some of these with the labels on them. Let's do number 12 since I got that one in the back. Okay, so number 12 is betadine. It says read the following labels and interpret the weight of the active ingredient on the label as well as the total weight in the container. So first we want to know the active ingredient on the label. Now what does it say is our percentage here?
10%.
10%.
So it'd be 10 active.
So when we set this up, what are we going to put?
10 over 100.
10 over 100 is equal to X over 100, right? Because it's wanting us first to figure out the weight on the label, so 10 grams, basically. So now we want to know total how much. So we already know this is our ratio here. So now we want to know active ingredient in the whole thing. How many milliliters is in the whole thing?
Well, it's 3.78 liters.
3.78 liters. So how many milliliters is that?
378 million. No,
just 78.
milliliters? No, million
You
milliliters.
got to move it 3 times.
Yeah.
Your decimal. It's actually 3,780.
How much is in there?
3.78.
That's 3.78 liters. You got to move it. Okay, so this is how you figure this out. It's just like any other. Okay, so it's 378 is your answer. That's how many grams of active ingredient you have in the whole bottle.
Okay.
Okay, does that make sense?
Yes.
Just make sure you read the instructions and what it's asking you so you'll know how to answer it.
Sure.
Just go, you might write this down on your formula chart too. Okay, so you'll have that in your mind and you can use that whenever it comes time for the test. You can use your formula chart and it'll have that on there. And this could be in milliliters or grams, and this could be in grams or milliliters. So I put both of those on here. Okay.
Are you going to print off these sheets for us?
Oh, yes. I'll print them out and I'll give them to you in anatomy.
Okay.
Okay.